Hello everyone, you're welcome once more to NEPH. And if you're new to the channel, you're highly welcome. Do well to subscribe to the channel and share the link of this channel to some students out there that needs to work on his or her skill in maths. Alright, like we can see today on the board, we are going to be talking about calculus. Okay, this is one area in mathematics I have discovered most students find it very challenging. Okay, most especially when you want to go into sciences and engineering, be it in mechanical engineering, robotics, okay, be it in aeronautic engineering or whatever kind of engineering that you want to go into, you have to be very, very sound and good, in what doing what, attempting or resolving questions that ask to do with what calculus. All right. So let's just get the basics. Okay, this is just an introduction to calculus. Right, so calculus, the word is Latin. Okay, now from Greek origin, in the times past, small stones and pebbles were used for counting and doing simple arithmetic what calculations. All right, so those small stones or pebbles were called what calculus. Okay, so that is the roots behind this word calculus. So calcul, okay, we have calcul, so that is the calculus. Okay, now we can also break this to calci, okay, and what's loose, okay. Calci has to do with the behavior and loose has to do with function, okay. So with saying all this, what's the meaning, okay, of the word calculus? It's a branch, okay, of mathematics that deals with what? How things, okay, change. So calculus is simply a branch of mathematics that deals with what, how things what change. Now next we are going to be looking at the types of what calculus. Now with regard to types of what calculus, okay, we have differential calculus and we have integral what calculus. Okay, so what do we mean by differential calculus? Differential calculus has to do with what? It talks about, the rate of what change, okay? So most times when we say differential calculus, it has to do with the rate of what change of what quantities, all right? And we can, bring that to things like sciences, physics, where we have a rate of change. When we say rate of change has to do with time. So example, we have speed, we have velocity, okay? Now, differential calculus can also, be referred to as what we can still call this word slope, or sometimes we can still call it what gradient, okay? These are terms you want to what be acquainted with so that, while we, solve problems on calculus, you should be able to know that these terms also refer to what? Differential calculus. We can sometimes also refer to it as derivative. Now we use this symbol d over what? dx. Okay? D over dx. So here we could have any what letter. Sometimes this can also have what any letter depending on the two variables you are comparing their rate of what change. Okay, so most times we have the symbol to represent what calculus. Now what about integral calculus? Okay, now for integral calculus, it has to do with what area? Okay, the area of a region. Most times where it called what area? Okay, the total area or the accumulated area of curved what surfaces. Okay, and we use this symbol, okay, like an S shape, okay, to represent what? The integral, okay. Now, differential and integral, they are just opposites. So if I work on a problem, okay, if I differentiate a problem, okay, and whatever value or answer we get, where we integrate it, it brings us back to this, okay? If I differentiate, it takes us to whatever value we have here, and whatever value we have here, if we integrate it, it brings us back to this. So it is just this cycle, okay? Where when you differentiate something, you have a value. When you integrate that value, it brings you back to what? The differential what? Value. Right. So the first thing we want to look at when it comes to calculus is we want to be understanding what we call gradient or what slope. Okay. That's especially of what is straight line, because when you, for instance, if I have a graph, okay, and for the straight line, an object moves from this point to this point, okay? There is what? A change, okay? So if, let's say, this is the y-axis and this is the x-axis, if I can, put this as a function of time and put this as a function of distance, okay? It is connected to what the rate of what? Change of what? One quantity towards another, all right? Now, if this object moves from this point, okay, let's call this line AB, okay, and this object moves from this point to this point, okay, there is a change. Okay, at first the object was here, we can call this point x1 and this point y1. Now the object has come here, so there is a change of what position. So once there's a change of position, it means there are changes in what? The values of what? X and what? Y. So now, from this point, we have a point which we have x1. Now, the object has come to another point on this line of what? X, which we have, let's call it x2. Now, if we also make reference to where it is, on this point, we have it as y2, okay? So you can observe that, there is an increment or there is an increase. Let's say this is 1 and this is 2, okay? This has increased by 1 or plus 1, okay? Or by x2 minus x1, okay? And this is 2 and this is 4. It means this has increased by 2, okay? Let me just put numerical values. So if this is 2 and this is 4, and this is 1 and this is 2, so there is what? An increment or change. And what is that increment or change? Okay, for x, direction of x, we have this is the change. We can use this, change x. Now for y, okay, this is the change. So we have this. Okay. Now in calculus, we can also say the change in y is also called dy. Okay. You say dy. Then the change in x we can also call dx, which we can call dx. Okay. Now, this distance from here to this point is what we refer to as the slope or the gradient. Okay. So you may be asked to calculate the gradient. And if you're asked to calculate the gradient, of what? A straight line, okay? So the slope or gradient most times we use delta n is simply what? The change in y divided by what? The change in x. Okay? So what that means is this vertical distance, okay, this vertical distance, okay, you want to use this vertical distance and divide what the horizontal distance, okay? So our grade or slope is simply what? The change in y divided by what? The change in x. We can also refer to it as what? Dy divided by what is the x. Okay? So, for instance, let's use the numerical values we have here. and calculate the slope. So I have, now we can write this as x2 minus x1, for this horizontal, and y2 minus y1 for the word vertical. So we can say y2 minus y1 divided by x2 minus x1. Okay. Now, if we input these values to 1, 2, 4 into this, we are now being able to calculate the slope for this what case. All right, so let's do that. So y2 is 4, so we have 4 minus what? Y1 is 2, so divide by what? We have x2 as what? 2 minus what? x1 as what? 1. Okay, so what would that give us? Okay, so that will give us n is equals 4 minus 2 is 2 divided by what? Okay, 2 minus 1 is also what? 1. So 2 over 1, n is equals to what? 2. Okay, because 2 by 1 is 2. So the gradient or slope, okay, or sometimes the derivative of the straight line is what? 2. Okay, so this is a basic knowledge or understanding you want to get about what calculus. And we can simply refer this as the dy over the dx, or the change in y over the change in what x, in this case, which is equal to n is equal to what? 2. Now, just to summarize it up on the introduction to calculus for all that we have done, we have come to realize if we have a straight line graph, and if we have 2 points, okay, and we have this point as x1 and this point as x2 is our x-axis, and this is our y-axis. We have this point as y1 and this point as what? y2. So this point, if we call it, let's say point A, we can label it what? x1, y1, okay? Or we start with x before y. Now this other point, we'll call it point B, we'll also start with what? x2, y2. This is x2 meeting y2. So we also have this as our change in what? X, which is x2 minus x1. And this we have as our change in what? Y, which is y2 minus y1. Okay, and we've come to also know that this length is also called n, which is what? Our what? Slope or gradient. And it is giving us what? N is equals to what? dy over what? dx, or change in y over change in x. Okay, so these are the fundamental things you need to know on calculus. All right, and just for your information, you can also visit, studying, basic mathematics on limits and continuity. Okay, and when you practice limits and continuity, is also going to help you, as we move forward in learning more deeply on calculus. Okay, now in terms of limits, you want to go and study positive limits, negative limits, and infinite or infinity limits. Okay, so why not go and review those before we come to what our next what series on what calculus. Thank you guys for watching this video. Hit the like button and don't forget to subscribe to this YouTube channel and share this video soon. I'll see you guys in the next video. Bye.